OpenBSD inside VirtualBox, first we need to download the VirtualBox. Go to VirtualBox download and then click Windows host. Start download, and after that continue the installation of the VirtualBox. Then open the OpenBSD official website. Click download and then click AMD64 to download the OpenBSD ISO file. After that, open the VM VirtualBox. Click new, name it as OpenBSD. Choose BSD as type and version OpenBSD. Click next and do some setup based on what your computer needs. Then click start and add the OpenBSD ISO file. Here, we need to do some setup and installation. After that, power off the machine and go to the system setting. Set hard disk at the top of the boot order. Then click start. Here, we need to log in. Then type clear and type start as. Press enter. Then the installation is done.
Okay, so now I will show to you how am I connect the host with the OpenBSD OS. As we use VirtualBox for our virtual machine workstation, we have to go to the host network manager in the virtual machine file tab to create the new adapter. Here, we will use the host on the adapter as our network in the OS setting later. As you can see here, this is our host IP address, and to know the OS IP address, we have to look at the DHCP server tab here. And then, open the virtual machine settings and go to the network and tick the Enable Network Adapter and attach to the host on the adapter to choose the previous adapter that we set on. Now, to verify that our network adapter is working, we will use Wireshark to capture all the activities. We can see the network adapter is according to our specific virtual network that we create just now. Now, start the OpenBSD OS and wait for a while. Here, we need to insert our login, username and password same as we set up earlier. Now, if we want to reconfirm our IP address, we can type ifconfig in the OpenBSD terminal or ipconfig in the host or computer command prompt, which is CMD. As you can see here, this is the same IP address that we found before. Next, we want to see if we can connect both hosts and our OS with type ping i3 nc1 192.168.114.1 in the OpenBSD. So now it is shown that 0 packet loss. It means we are done success pinging from OS to the host. Here, we ping in the OpenBSD OS using the host IP address. Now, let's analyze in the Wireshark. It is shown that the request and reply from OpenBSD to the host. Now, let's try on the host CMD. When we ping in the host using OpenBSD's IP address with ping n1 i3 192.168.114.3, the same result occurred, which is it shows that the request and reply from host to OpenBSD. So here we can conclude that the request and reply between both of them is success.
OpenBSD. The OpenBSD project produces a security-focused, free and open source, multi-platform 4.4 BSD-based Unix-like operating system based on the Berkeley software distribution BSD. The effort emphasizes portability, standardization, correctness, proactive security, and integrated cryptography. As an example of the effect, OpenBSD has the popular OpenSSH software comes from OpenBSD. OpenBSD is freely available now. The current release is OpenBSD 6.9, released May 1, 2021. This is the 50th release. OpenBSD is developed entirely by volunteers. The project's development environment and developer events are funded through contributions collected by the OpenBSD Foundation. Contributions ensure that OpenBSD will remain a vibrant and free operating system. Theodora created OpenBSD in 1995 by forking NetBSD. The OpenBSD project maintains portable version of many subsystems as packages for other operating systems. Because of the project's preferred BSD license, many components are used in proprietary and corporate-sponsored software projects. The firewall code in Apple's Mac OS is based on OpenBSD's PF firewall code, while for Android's Bionic C standard library is based on OpenBSD code. LLVM uses OpenBSD's regular expression library, and Windows 10 uses OpenSSH, OpenBSD's secure shell with LibreSSL. The word open in the name OpenBSD refers to the availability of the operating system source code on the internet. Although the word open in the name OpenSSH means OpenBSD, it also refers to the wide range of hardware platforms the system supports.
Next, I will show you how to perform the NMAP scan flag for TCP protocol. At first, I will scan flag of 2 with writing some commands in the command prompt nmap n pn scan flags 2 p 80 192.168.114.3, which is the OpenBSD IP address. In this command, I am using port 80 and scan flag of 2. As you can see here in the CMD, it states there the port 80 is closed, so it will let the host to send SYN packet to the OpenBSD, and then the OS will respond with RST indicating the connection is terminated in the port 80. Then for the flag of 4, I will just change the flag in the command prompt from 2 to 4 and run it. Based on the Wireshark analysis, host send packet to the OpenBSD, then the OS will respond with RST where it terminated the connection, also indicating that the port 80 is filtered. Lastly, for the flag of 64, with command nmap n pn scan flags 64 p80 192.168.114.3, here in the Wireshark, the host sent ECN packet to the OpenBSD OS.
TCP SYN scan default command nmap ss IP address. This command will initiate a TCP SYN scan against the target host. A TCP SYN scan sends a SYN packet to the target host and waits for a response. If it receives an ACK packet back, this indicates the port is open. If reset packet is received, this indicates the port is closed. If no response is received after multiple transmissions, the port is considered filtered. A device or application between the source and the target is filtering the packets. TCP connect scan command nmap st IP address. This command will initiate a TCP connect scan against the target host. A TCP connect scan is the default scan performed if a TCP SYN scan is not possible. This type of scan requests that the underlying operating system try to connect with the target host or port using the connect system port. UDP port scan command nmap su IP address. This command will initiate a UDP port scan against the target host. A UDP scan sends a UDP packet to the target ports. If a response is received, the port is classified as open. If no response is received after multiple transmissions, the port is classified as open or filtered. SCTP init scan command nmap sy IP address. This command will initiate a SCTP init scan against the target host. SCTP init scan is similar to the TCP SYN scan but specific to the SCTP protocol. init chunk is sent to the target ports. If an init ACK chunk is received back, the port is classified as open. If an abort chunk is received, the port is classified as closed. If no response is received after multiple transmissions, the port is classified as filtered.
Last but not least, I will demonstrate how to scan flag using Python. First thing first, we need to prepare the code as shown and make sure there is no error by checking the module before run it. After the code is ready, we have to capture the packets using Wireshark and filter it into a specified IP address by typing ip.dsd equal to 192.168.114.3 and TCP, which is the OpenBSD IP address as the IP destination. Then, we can start running the module and enter the specified IP address, which is the OpenBSD OS IP address, and enter the number of flags that we want to send. I am entering all numbers from 1 until 256. After that, we can see what type of flags that we send using Wireshark. So now, as you can see here, the first line is when I send number 1, we are requesting fin flag. For number 2, SYN flag. For number 4, RST flag. Number 8, PSH flag. Number 16, ACK flag. Number 32, URG flag. Number 64, ECN flag.
In conclusion, NMAP is a good tool for network scanning and auditing purpose. NMAP lets us to quickly scan and discover essential information about our network, host, ports, firewalls, and operating system. It has numerous settings, flags, and preferences that help us analyze the network in detail. To understand NMAP in a better way, we need to learn how it does scan or diagnose the network system. That's all from us, and thank you for your attention.